Hello viewers, welcome to Geeks for Geeks. In this tutorial we will be looking at how to find if there is a subarray with zero sum. We will be given an array of positive and negative numbers. We have to find if there is a subarray of size at least 1 with zero sum. Let's look at an example. If the input array is this, our output should be true. There is a subarray with zero sum from index 1 to 3. This is another example. Our output should be false as there is no subarray with zero sum. A simple solution is to consider all subarray one by one and check the sum of every subarray. We can run two loops. The outer loop takes a starting point I and inner loop tries all subarrays starting from I. The time complexity of this solution is big O of n square. This is a better solution. We are using hashing here. The idea is to iterate through the array and for every element, array I calculates sum of element from 0 to I. This can simply be done as sum plus equal to array I. If the current sum has been seen before, then there is a zero sum array. Hashing is used to store the sum values so that we can quickly store the sum and find out whether the current sum is seen before or not. Let's try to understand this using an example. The input array is this. First we'll find all the prefix sums. These are the prefix sum of above array 1, then 1 plus 4 that is 5, then 1 plus 4 minus 2 that is 3 and so on. There will be a subarray with zero sum only if either of these two conditions satisfies. First, either a prefix sum repeats or prefix sum becomes 0. In this case, since prefix sum 1 repeats, we have a subarray with zero sum. Let's look at the code. We make an empty unordered map called sum map, which stores an int and boolean. We will start traversing through the array and store prefix sums. If sum comes out to be 0 or it is already present in the sum map, then we will return true, else we store the prefix sum and continue the loop. After completion of loop, if this condition doesn't satisfy, then we will return false. Time complexity of this solution can be considered as big O of n under the assumption that we have a good hashing function that allows insertion and retrieval operations in big O of 1 time. Thank you for watching. Please leave us your likes and comments.